On April 17, 2025, NASA released data that could fundamentally transform our understanding of the cosmos. Signs of life were detected on a distant planet with a probability of 99.7%. The planet in question is K2-18b, located 124 light-years away from us. In its atmosphere, chemical compounds were identified that, on Earth, are almost always associated with living organisms. Moreover, their concentration is 1,000 times higher than on our planet. If these substances are indeed the result of biological activity, as they are on Earth, then right now this world could host not just life, but a true ocean of biological diversity. What is striking is that everything suggests K2-18b is a water world, a planet covered by deep oceans that may conceal active life, potentially completely unlike anything found on Earth. 2015. The Kepler Space Telescope begins its K2 mission, Second Light, exploring the depths of space. During this mission, it discovers more than 1,200 distant planets. Among them, one stands out in particular, a planet with intriguing signs of potential habitability. It is nearly 2.5 times larger and almost 9 times more massive than Earth. Scientists name it K2-18b. 2016. The Spitzer Space Telescope joins the investigation and confirms that K2-18b lies within the habitable zone, the region where liquid water could exist on a planet's surface. Almost simultaneously, an astronomical observatory in Chile, using the highly precise HARP spectrograph, determines the planet's density, suggesting the possible presence of an ocean. It becomes clear that the stakes are rising. More and more evidence indicates that life could exist on this planet. 2019. The Hubble Space Telescope makes another discovery. Water vapor is detected in the atmosphere of K2-18b. The possibility of a deep ocean capable of supporting life no longer seems like science fiction. Hope becomes tangible. 2023. The most powerful modern telescope, James Webb, JWST, joins the effort. Its sensors detect something that immediately shocks scientists. Traces of a chemical compound, dimethyl sulfide, DMS, a substance that on Earth, with rare exceptions, is almost always produced by living organisms, particularly phytoplankton and other marine microbes. If this is not an error, scientists may have, for the first time in history, detected signs of life beyond Earth. However, there was still no certainty. There is always the possibility of error. The data could have been distorted, especially since the initial detection was made using only one instrument, the James Webb Space Telescope's near-infrared camera. And distinguishing dimethyl sulfide from, for example, methane in that wavelength range is extremely difficult. Scientists were left with a logical question. What if this is an instrument glitch, or an artifact of the measurement process? To verify this, NASA decided to conduct follow-up observations using a different instrument and an entirely different method. If both independent instruments produced the same result, it could be declared a genuine discovery. On April 17, 2025, the James Webb Space Telescope used a new instrument to rescan planet K2-18b in detail. This time, it employed a mid-infrared camera. The results were striking. Traces of dimethyl sulfide were detected again, and its concentration may be enormous, up to 1,000 times higher than on Earth. This is not just an unusual gas. Dimethyl sulfide is relatively rare on Earth. It is produced when microscopic algae, such as phytoplankton, begin to decompose in the ocean. During this process, the gas is released, easily evaporates, and enters the atmosphere. If you have ever walked along a seaside coast on a windy day, you have almost certainly smelled it. It is dimethyl sulfide that creates that unmistakable sea-like scent. But it's not just about the smell. This gas has a crucial property. It is highly unstable in an atmosphere. Its lifetime lasts only a few days. It quickly breaks down under the influence of sunlight and oxygen. This means it cannot simply linger in the air. It must be constantly replenished. And on Earth, this replenishment is almost always linked to living organisms. That is precisely why the discovery caused such excitement in the scientific community. The concentration of dimethyl sulfide in the atmosphere of K2-18b turned out to be 1,000 times higher than on Earth. What could this mean? Given how rapidly this gas disappears, There is only one logical explanation. If its source is biological, as it is on Earth, then something must be alive on K2-18b, and not just existing, but on such a scale that it continuously sustains such an extremely high concentration of dimethyl sulfide in the atmosphere. Detecting this gas from a distance of 124 light-years sounds almost like science fiction. Yet, the James Webb Space Telescope has made it a reality. The method is truly remarkable. Each time K2-18b passes in front of its star, a fraction of the starlight travels through the planet's atmosphere. Although this is only a tiny portion of the light, it carries a vast amount of information. The atmosphere acts as a filter, absorbing specific wavelengths of light depending on which gases are present. These changes in the spectrum are like clues left by the planet itself, which the telescope records and sends back to Earth. Astronomers collect these clues, analyze them, and reconstruct the chemical composition of the atmosphere. In other words, we are effectively reading the atmosphere of a distant planet through the light of its star. But to truly understand what might be happening on K2-18b, we need to examine the conditions in which it exists. The planet orbits the star K2-18, a cold red dwarf located 124 light-years from Earth. Its orbit is extremely close to its star, about 2.5 times closer than Mercury is to the Sun. However, the star itself is much smaller, cooler, and dimmer than our Sun. Thanks to this delicate cosmic balance, K2-18b receives roughly the same amount of heat and light as Earth. This is why it is considered potentially habitable. Scientists classify it as a so-called Hycean planet, a hypothetical type of exoplanet proposed in 2021 that may be entirely covered by a deep ocean and enveloped in a thick, hydrogen-rich atmosphere. In addition, it has been found that there is no ammonia in the atmosphere of K2-18b, which further supports the hypothesis of large amounts of water on its surface. Ammonia would simply dissolve in the ocean. However, despite all these promising signs, there are also serious doubts. If the planet is indeed covered in water, it may be too hot, so hot that life in any Earth-like form could not exist. Temperature, pressure, and chemical conditions could turn the ocean into a boiling inferno. Moreover, debates about the planet's true nature are still ongoing. Some scientists, including Dr. Nicholas Wogan of NASA's Ames Research Center, argue that K2-18b may not be an ocean world at all, but rather a miniature gas giant with no solid surface. If that is the case, the chances of life on this planet would drop almost entirely to zero. However, the lead researcher of the project, Professor Niku Madhusudan of the Institute of Astronomy at the University of Cambridge, takes a much more optimistic view. His team was responsible for detecting the dimethyl sulfide signal, and he is convinced that K2-18b truly has an ocean and could potentially host life. According to him, within the next 1 to 2 years, scientists will be able to determine with near total certainty whether this gas is truly present in the planet's atmosphere and whether it is the result of biological processes or has another origin. For now, scientists estimate the probability of potential biosignatures in the atmosphere of K2-18b at an astonishing 99.7%. This is the highest level of confidence ever recorded in the search for biosignatures beyond Earth. As promising as all of this may seem, scientists at the University of Cambridge are proceeding with caution. It is still too early to announce a breakthrough. To confidently claim the existence of life on K2-18b, researchers must first confirm the presence of dimethyl sulfide in its atmosphere with a reliability of 99.9994%, and only then can they demonstrate that this gas is indeed of biological origin, in the same way it is produced on Earth. If this is confirmed, we would be witnessing a truly extraordinary event, the first genuine evidence of extraterrestrial life in history. But even more striking is not only the possibility of life itself, but the location where it may have been found. K2-18b lies just 124 light-years from Earth, roughly 730 trillion miles. For us as humans, this distance feels completely insurmountable. Even sending a human to Mars remains an enormous challenge, let alone interstellar travel, which may forever remain beyond our reach. However, when viewed on the scale of the universe itself, 124 light-years is not just small, it is barely a speck on the map. The universe spans about 93 billion light-years, and if life were discovered on a planet only 124 light-years away, it would be like saying, the entire universe is your home, and what you were searching for all your life was in the storage room of your apartment. It would mean that if life exists there, it could exist anywhere. Such a discovery would completely reshape our understanding of how widespread life might be in the cosmos. For now, this remains only a hypothesis. Research continues, and despite the scientists' caution, one thing is clear. Humanity has never been closer to answering the greatest question of our existence. Are we alone in the universe? While scientists continue the search for a definitive answer, we can briefly look ahead and imagine what life on this mysterious planet might be like if it truly is inhabited. It is logical to begin with the simplest forms. On Earth, life began with microscopic organisms, and it is most likely that life on K2-18b would have followed a similar path. The primary candidates would be microbes capable of surviving in a hydrogen-rich atmosphere under high pressure and temperature conditions. They might resemble Earth's extremophiles, microorganisms that live on the ocean floor near hydrothermal vents, where temperatures exceed 100 degrees Celsius. These organisms do not depend on sunlight, instead deriving energy directly from chemical reactions such as the oxidation of hydrogen sulfide. On K2-18b, such chemical reactions could be widespread, given its hydrogen-rich atmosphere and possible volcanic activity. If life on this planet managed to evolve beyond the microbial stage, a fascinating question arises. What might more complex life forms look like under such conditions? A deep ocean beneath a thick atmosphere would likely be almost entirely devoid of light, meaning vision would not be the primary sense as it is on Earth. Similar to organisms living on the depths of our oceans, inhabitants of K2-18b might navigate using vibrations, heat, magnetic fields, or chemical signals. Some could even evolve bioluminescence, the ability to emit light, like fireflies or anglerfish on Earth. Particularly intriguing is the potential size of such organisms. In a hydrogen-rich atmosphere, where the medium is less dense than on Earth, organisms could gain advantages in growth. Hydrogen is lighter than air, meaning buoyant forces would be stronger, potentially allowing the evolution of much larger life forms than on Earth. They might be slow-moving, with massive bodies adapted to extreme pressure and dense water, something like giant jellyfish or amorphous drifting creatures inhabiting the warm depths of the ocean, or even floating within the atmosphere itself. In addition, adaptation to colossal pressure would likely be a key feature of such organisms. The ocean on K2-18b could be far deeper than Earth's, and if diverse life exists there, some organisms might comfortably inhabit depths of 10 to 15 miles, where pressure reaches 1,600 to 2,400 atmospheres, far exceeding that of Earth's deepest point, the Mariana Trench. To survive under such extreme conditions, life on K2-18b could develop bodies capable of withstanding immense pressure. The first obvious adaptation would likely be a strong but flexible outer shell, protecting internal structures from compression. These organisms might possess dense, almost cartilaginous or skeletal frameworks made of robust biopolymers, several times stronger than those found in Earth life. One could imagine creatures with exoskeleton-like structures, coated in specialized materials capable not only of resisting extreme pressure, but also of distributing and minimizing its impact on internal tissues. These structures could resemble the frameworks of exoskeletal organisms such as crabs, but be several times denser and far more resistant to deformation. Their bodies might be covered with a tough biological armor or shell that is simultaneously flexible and strong. Of course, all of this remains purely speculative. We do not know what kinds of chemical reactions could sustain the metabolism of potential life forms on this planet, if they exist at all. We do not know which molecules might perform a role similar to DNA on Earth. But if the detected dimethyl sulfide is indeed produced by living organisms, it would mean that life there is not only possible, it has already adapted. And who knows, perhaps right now, in the warm depths of a distant ocean, slow-moving creatures exist in a world that is as alien and unreachable to us as ours is to them. Although K2-18b is currently considered one of the most promising candidates for extraterrestrial life, it is far from the only one. Meet another fascinating world, K2-18b. It lies just 12.5 light-years away from us, cosmically speaking, practically next door. Scientists estimate that the probability of Earth-like conditions on this planet is around 60%. Moderate temperatures, likely ranging from 0 to 50 degrees Celsius, liquid water, and a relatively stable climate. All of these may characterize K2-18b. However, and this is a key point, such conditions, if they exist, would most likely be confined to a narrow transitional zone between the planet's day and night sides. The reason is that the planet is likely tidally locked, always showing the same face to its star. This means that one hemisphere is in perpetual daylight, while the other is in eternal darkness. As a result, extreme temperature contrasts arise, from scorching heat to freezing cold. It is precisely at the boundary between these two worlds that a permanent twilight zone exists. In this region, a temperate climate could be maintained, liquid water could exist, and therefore life, possibly even complex multicellular organisms, might be possible. Another intriguing planet where life may exist is Kepler-1649c. It was discovered in 2020 and lies about 301 light-years from Earth in the constellation Lyra. Despite its distance, it has several characteristics that are of particular interest to scientists. This planet orbits a small, dim star, a red dwarf with about 1/5 the Sun's mass and roughly 1/4 its size. As a result, the planet receives about 25% of the light and heat that Earth receives from the Sun. The planet itself is slightly larger than Earth. Its radius is about 6% greater and its mass about 20% higher. Therefore, surface gravity would feel quite familiar, neither too strong nor too weak. However, like K2-18b, Kepler-1649c is also likely tidally locked. This could create extreme conditions, one side too hot, the other frozen. Yet, as on K2-18b, a so-called twilight zone between the day and night sides could maintain a stable climate with Earth-like temperatures and the presence of liquid water. It is within this narrow band between light and darkness that life may be possible. Primitive life could potentially find refuge. TOI-700 is another fascinating candidate for habitability. This planet is located in the constellation Dorado, about 101 light-years from Earth, and was discovered in 2020. It is the third and most distant planet in the TOI-700 system, and possibly the most intriguing of all. Unlike K2-18b and Kepler-1649c, which are likely tidally locked and always show the same face to their stars, TOI-700 may not yet have undergone this effect. Because of this, it may still experience a day-night cycle, leading to a more stable and life-friendly climate. The planet receives about 86% of the sunlight Earth receives, slightly less, but still sufficient. Its estimated average surface temperature is around -4 degrees Celsius. Cold, but not prohibitive. And if even a modest greenhouse effect exists, conditions could be significantly milder. In terms of size, TOI-700d is slightly larger than Earth. Both its mass and radius are somewhat greater, meaning surface gravity would be slightly stronger, but still comfortable for potential life. Another advantage is that the host star, TOI-700, is relatively quiet. It does not produce powerful flares or stellar storms that could strip away the planet's atmosphere, a rarity among red dwarfs, most of which are highly unstable. This stellar calm increases the likelihood of a long-lived atmosphere, stable oceans, and possibly even life. Of course, we cannot yet say exactly what is happening on the surface of TOI-700d, but increasing evidence suggests that this planet firmly belongs among the most promising exoplanet candidates we currently know. However, not all potentially interesting planets resemble Earth. Some of them seem as if they have stepped straight out of science fiction. And J1407b is one of the strangest planets ever discovered by scientists. Located about 434 light-years from Earth, this planet is a true Saturn on steroids. Studying its world is extremely difficult. Its mass is hard to determine precisely, but estimates suggest it ranges from 10 to 40 Jupiter masses. J1407b is a gigantic planet, far larger than the biggest planet in our solar system. But what truly amazed scientists is its colossal ring system. It consists of 30 rings, each tens of millions of kilometers in diameter. Rough estimates suggest that the entire ring structure spans about 120 million kilometers, roughly 200 times larger than Saturn's rings. If Saturn had such a ring system, it would dominate our night sky. But while it would be a breathtaking sight, it would not last long. Over time, the rings would thin out as numerous moons would form around the planet. And this is only the beginning. The universe still holds many more bizarre worlds. Now let us move to the constellation Cygnus. There, about 650 light-years away, lies a hellish world, K2-18b, with a mass of only 0.44 Earth masses and a radius about 0.75 that of Earth. It is one of the hottest exoplanets known to us. The star Kepler-70 was once a main sequence star similar to our Sun, and Kepler-70b was originally a Jupiter-sized gas giant. But about 18.5 million years ago, the star entered its red giant phase. As a result, the planet spent a long time engulfed within the star's expanded envelope, and only its hot iron core remained. Scientists believe the planet is still evaporating and may become even smaller over time. Just how hot is it? Since Kepler-70b orbits 65 times closer to its star than Mercury does to the Sun, its surface temperature reaches an astonishing 6,650 degrees Celsius. For comparison, the surface temperature of our Sun is only about 5,500 degrees Celsius. So if hell exists, it would certainly be here. The final exoplanet on our list is K2-18b. Its uniqueness lies less in its intrinsic properties and more in the system it belongs to. This planet, about twice the size of Saturn, was initially overlooked due to the difficulty of studying it and was even once dismissed as science fiction. However, decades later, the K2-18 system finally received the scientific attention it deserved. It turned out that astronomers had stumbled upon a triple star system. The planet orbits star A, which has a relatively close companion, star B. The two orbit each other every 30 years. But there is also a third star, star C, gravitationally bound to the other two. It completes a full orbit around stars A and B every 400 years. If we somehow found ourselves on this exoplanet, hovering at the edge of its atmosphere in a spacecraft, an extraordinary and surreal landscape would unfold before us. Below, we would most likely see dark brown and gray clouds. And instead of a single sun, we would see two, one about 17 times larger than our Sun, and another much smaller, only 0.5% brighter than the Sun. Yet even this faint star would shine 1,000 times brighter than a full moon on Earth. Despite the astonishing nature of these alien worlds, even stranger celestial objects may exist in the universe. For now, they remain hypothetical, but some scientists argue they could be entirely real. According to this hypothesis, such enigmatic worlds could form from the collision of gas and dust around black holes. They could also develop at vast distances from supermassive black holes, with orbits lasting millions of years. The universe has no limits, not only in distance, but also in its creativity. From time to time, astronomers discover such astonishing objects that they expand our understanding of the world we inhabit. It took years to uncover all the planets in our solar system, and they continue to surprise us with their properties. So who knows how many more discoveries are waiting for us among the more than 5,000 already known exoplanets?